Concepcion with Scales Industrial Technologies. Here at Scales, we have the capabilities to design a project from the bottom up, and one of the more recent projects we handled involved a chilled water system. In this video, we'd like to go over the details involved and what was required in order to fulfill the customer's needs.
Their existing equipment was serviced by individual chillers, if you will, and dedicated chillers. And we wanted to go to a central system. It was advised by us to go with a central system, incorporate all the new equipment, all the old equipment, and into one final system. So we started at the beginning with their equipment, evaluating what the heat loads were on each piece of equipment, and then coming up with a tally of what we needed, and then we calculated the water flow required, and we came up, with a total chiller size for that system. The location of the chiller is outdoors. It's an air-cooled chiller and outdoors at ground level, or the same level as the plant. They were not able to put it on a roof. Had they been able to put it on the roof, we may not have needed to go with a glycol loop, because you can drain down all the water when the chiller is turned off. You drain it down into a tank. But in this case, it wasn't possible to drain out the water during shutdown, so we devised a glycol antifreeze loop with a plate and frame heat exchanger and pumps, etc., that the chill is cooling the glycol, and the glycol is cooling the water, the processed water. The processed water is cooled by the heat exchanger. It's then directed into a main manifold, processed water manifold, which takes the water and delivers it to the entire system. A portion of the water cools the granulating machines. Another portion of that same water goes through the molding machines. The return water from both of them items comes back to the tank at the pump package, and then was recycled back through the chiller or the heat exchanger, etc. And then the third portion of that water is sent to the mix tank. The mix tank is for that pastellator, which requires, each one of them require 106 gallons of water a minute. That water flow for 4 machines being 424 gallons a minute, it's impractical to run that back through the chiller. In addition, it's only a 1 or 2 degree rise. Mixing tank is to take the water off from this machine, even though it's a low temperature rise, and mix chilled water with it to cool it down, and therefore it goes back cooled. That's how we're cooling that water. And that's in its own circuit or loop, as you know. We've got that water pump, a 25 horsepower, 20 horsepower water pump to do that. But then we take a portion of that water in the mixing tank and send it back to the chiller to be cooled. All right? So it's a heat exchange takes place in the mixing tank for that particular piece of equipment. When we completed the project and put it online and tested all the equipment and put their system up and running, it performed as specified, as we had guaranteed that it would. The project was quite successful and the client was extremely satisfied. They felt confident knowing they had a project that is performance guaranteed. So give us a call so we can show you the benefits of doing business with Scales Industrial Technologies.